Okay, welcome to 3311. I am your instructor. Let me just go through certain administrative issues first, and then we will talk about syllabus, and then we'll talk about the course contents, okay? But today we'll do Java. That's the only class we'll do Java for the semester, for good reason, okay? I'll show you. Okay, let's talk about some administrative issues here. But if you got any concern, do interrupt me. So I want to clarify everything as much as possible. First about me, so just call me Jackie, okay, or other names. And my office is Lassam Building 2043. For this semester, my office hours will be 4 to 6 p.m., Tuesday, Wednesday, and Thursday. You can always talk to me about the course contents, or just send me an email to make appointments, okay, either way. And you should really speak to me early about getting advice for the course. Please don't speak to me when you actually fail that. You actually are failing the course. Okay, speak to me earlier so I can give you advice to see how you can succeed. And throughout the semester, if you think there's anything I can do to improve your learning in the lecture, tutorial videos, in the labs, just send me an email or just talk to me. Okay, I'm always open to suggestions. Okay, course information. Okay, let me try to do this here. There are two Moodle sites, but Moodle today is hopelessly slow, so I'm not going to show that on the web, okay? But I can tell you that there are two Moodle sites on your page if you're officially registered. If you're still on the waiting list, talk to me after class. What I will do is I will add you to the Moodle site manually, which means you can still get access to Lab 0. And starting from next Wednesday, we'll get Lab number 1, okay? Okay, the first Moodle site you should have is Section A, specific to this section here. Over there, I would like, sometimes I might send some announcement only applicable to Section A. Maybe just to tell you that lecture materials for today is available. And also, you can post your questions related to the slides or anything you want to ask about the course on the forum. There's a forum there. I'm going to moderate that myself. And just never ever share solutions to projects or labs. I'm sure you know that pretty well. Don't do it. Okay, the second Moodle site is shared by the other section as well. So go there mainly for instructions for labs. For example, lab number 0. Okay, there are certain information I would like to point out to you. Okay, as I said, Moodle is very slow today. I got a screenshot for you. So let me just show it to you quickly. So when you log into your Moodle site for section A and E, what you will see is, for now, you will see under important documents, I suppose most of you have already opened Starter Guide, right? Talking about how you can apply for educational GitHub account and how you can install iPhone Studio, the main IDE we're going to use for this course, and also to start a tutorial series, right? It's a long tutorial series, but as I said, believe me, it's worth doing, okay? And for the lab instructions there, it's Lab 0 for now. But maybe I would say Tuesday night next week, I'm going to post Lab 1. So when you come to the lab session on Wednesday, you can get prepared and ask questions. Normally, I go to lab sessions, so you can also come to ask me questions. And the required textbook, there's only one required textbook, and we got a permission from the author. So you can just get a PDF for free. You don't need to purchase that. If you want to get a paper copy, you can just go to Amazon or some online bookshop to get a second-hand or whatever. However, here's the warning. You're not supposed to use this book distributed to anyone else outside the course. Okay, that's kind of the precondition for using that book. Okay. Right, that's about the Moodle site. It's very simple for now, but later on we're going to add mainly just some lab instructions. Okay. Okay, 2 Moodle sites, and this is the main thing. So I record all my lectures. If technology didn't fail on me, I will record everything. I will make everything available to you. However, I want to encourage you, don't take this as a substitute for the lecture. Do come to class. I would like to see everybody here. Ask me questions, learn with your colleagues. I think that's the best way to learn. Don't just rely on your time at home to watch videos. It's very boring, okay? Okay, let me just show you very quickly how the website looks like. So if you click on the link, basically this EECS software design for this semester here, we already got the tutorial. I also included the links over here. You can just follow them. And then each lecture will be a single row, and then I'll give you recording on YouTube, iPad notes, and also source code and slides, etc. So all the learning resources will be here. It's completely open. So even if you are on the waiting list, there should be no excuse not to get started. Okay? Typically, I will try to make all the resources available on the day of the class, maybe just after the lecture, maybe before 7 p.m., before I go home. That's what I will usually do. I'll try. Any questions so far? Are we okay? Good. Okay, let's go back. Let's go back to the slides and check your emails regularly. So I will make a regular announcement to you for important information. Please, no excuse to miss the important announcement. Okay? Okay, class protocol. You guys are behaving very well, but let me just say this. No talking, no mobile, except you want to ask questions to me. Okay, let's follow that rule stringently for everybody. And if you really want to do it, please leave the classroom. I wouldn't mind. Okay? Okay, in the class, I really encourage you to slow me down. Sometimes I do have the pressure to really cover everything I'm supposed to cover, but I'm more concerned about how you learn. If you really want me to reiterate certain things in the class, please just stop me. I wouldn't mind. Okay? Yes? You know what? It's a good question. The question was, can you use your phone to capture the slide or my notes? You don't have to, because everything will be available.
I know, but that's just how I see it.
That's fine if you want to take photo, right? Just don't take a photo of me. All right? Yeah, that's fine. But guys, I say no mobile, just don't talk and don't just play. If you just come here and play your app, what's the point, right? You don't want to be distracted by me, just play outside. Yeah, if you want to take a photo, that's fine. Okay, each lecture will be recorded entirely. I just figured out a way this semester how to make high definition video, so you guys will see. So in the previous year, it's not really high definition, but this year it is. So you will see from today's recording. Okay, again, you shouldn't really not come to class just because I make recording, right? Again, come, contribute to the questions, and then make the lecture more interacting. Yeah? Just go to the lectures page I just mentioned, right? Go there, and then you will see the recording there. You don't need the Moodle access. It's completely accessible. The idea is for other sections, and also even if after you complete the course, you can still learn the materials. I keep all the materials there just for learning, right? Yes?
The lecture recordings that you have, are they captioned or are they just audio?
Caption? I believe you can just turn the caption on when you watch the YouTube.
I tried to click on it and there's nothing there.
So maybe, can I leave that maybe to you?
For the GitHub instructions, I looked and there was nothing there.
Well, maybe I can leave you guys to maybe do the interpretation. Would it be okay? Or maybe we can talk outside the class. Okay? Okay, let's continue. Okay, and then, so in the class, this is what I encourage you to do. Try to reach maximum comprehension, because sometimes we do talk about very advanced concept for design. So if you cannot really copy out everything I said in the slides or everything I say verbally, don't worry, it's recorded. You can always reiterate them. I want you to try to just comprehend as much as possible and ask questions. Yeah. Yes? I will have some tips. Yes, I do have some tips.
So should we be taking notes? Should we do
okay.
on the slide? Should we take notes on the slide?
You know,
Take notes ourselves?
I would suggest you don't have to copy anything that's already on the slides, but I do recommend it's kind of old school style of learning. When I was back your age, also at York, not this lecture room, but somewhere else at York. So what I like to write down usually is when the professor says something verbally without writing that, it's usually something that's important. Okay, I would suggest you try to copy something that's not really on the slides, or something that's not really on my iPad. For example, sometimes I might say, oh, this exercise here might be on the exam, right? In that case, you want to pay more attention to it when you reiterate. Okay? Actually, that's exactly the next point. So sometimes even take some incomplete notes. Maybe I say something not so clearly, just take some notes and then show it to me when you see me in person, so I can try to reiterate that with you together. So, yeah. I'll give you more tips just in general. But everybody got different learning styles, so I can only offer you my personal opinion. So this is you guys are third year, so I don't want to bother you too much with my personal opinion, but I'll just mention that quickly anyway. You don't have to agree, okay? To me, studying CS, if you want to do well, hard work is not everything. Inspiration, which means you want to be creative, You learn the principles and simple examples in class, but you have to think it through yourself outside the class and be able to apply to new problems, which will occur in the exam, midterm, and the lab test. Okay? That's why perspiration is important. Without that, you cannot succeed for sure. Wow, that's kind of cliche, right? So now, what does that mean? So now, every time when you think that you're working very hard, don't be just too satisfied yet. Try to check if you're really working hard on the right thing. What do I mean the right thing? So I would say you want to try to at least master whatever I talk about in the slides and also in the iPad notes illustration. They are the grounding stuff. They are the basic stuff. However, you should always stay on top to try to connect everything together in the class. When we talk about design by contracts, when we talk about design patterns, you want to think how they're connected together. Try to make some connection yourself. And by the way, you should always try to make connection to your previous courses. So we don't really teach courses in isolation. They should be somehow related. Maybe you'll find some concept sound familiar to something in 3101, or maybe something back in 2011. So always try to stay connected. You know, don't constrain yourself just to what I say, right? You want to study more and be curious. Be adventurous about go beyond the lectures. Maybe you can try to read more. For example, when you read through the required textbook, there might be some reference papers which you can get for free from libraries. You can also, out of your curiosity, you can also read them through, right? And then come to me for discussion, right? Okay. Final tip, you really want to reflect always and make sure everything stay connected. If you're not too sure to say, you can just come to ask me, why are you talking about this in this context over here? Why do we need contracts? Why do we need preconditions? Things like that, right? If you think it through, you don't quite agree with what I say, it's okay because it's university. You don't have to agree with everything I say. Disagree? Come to me with your reasoning. We'll debate. We'll discuss, right? That's how you learn. Okay. About academic integrity, I don't need to say too much. Just read through the slide, make sure you're aware of that. One thing I want to mention. So when you apply for the GitHub account, make sure it is educational because educational account allows you to store things in the private repositories. If you ever store your lab or project work in a public repository, it is considered plagiarism, cheating. It is considered that. So please, no excuse. It doesn't take long to apply. If you already got an existing GitHub account, just go there, follow the instruction there. You can easily convert that into educational, okay? It's easy to do, okay? The rest, just read it through. Okay, let me go through the syllabus about how the course is going to be evaluated and also the dates for the, we got one midterm and one lab test, okay? And then also one exam, but I'll show you to you in detail. Again, I don't want to go to the Moodle site. It's already on my computer here, but when you go to the Moodle site maybe later, this is what you will see, syllabus. Okay? Let me just make it wider. Okay, let's go through that. Okay? For the course description, I'll let you read it. There's no point to just read it through. For course learning outcomes, usually I think maybe the best point to review the course learning outcome is when we complete a course, right? When I mention anything to you now, it doesn't make much sense. Okay, let's not waste time. Okay, about the textbook. The required textbook, Object-Oriented Software Construction, usually I just refer that as OOSC2, just an acronym, okay? That one, as I said, is already available on the Moodle site for free, the PDF, okay? Unless you want to purchase a paper copy, it's completely up to you. And there will be several reference books. Since we're going to use a different language in this course, if you want to get more examples and more basics about contracts, you can feel free to get access to this textbook. Again, you don't need to purchase this. If you just go to Stacy Science Library online, type this, the name of the textbook is also free for you. Okay? If you're York students, just use the Stacy Science, just use the online library account. Okay, I got instruction on the syllabus. And the second reference book is called Design Patterns, Elements of Reusable Object-Oriented Software. So throughout the course, we're going to talk about a number of design patterns. So these are solutions to different recurring problems in the software industry. So we hope that when you complete the course, you will be equipped with the knowledge about when you see a particular problem, which pattern to apply. So there's no silver bullet. You got to judge which one should be the scenario to apply, right? So that's quite a good catalog book, but that one is actually written in C++. But you still can get an idea, right? It doesn't have to be just in Java or iPhone. That one there, unfortunately, we don't have a free copy for you. So if you want to get a free copy, maybe just get online shop or find it your way. Finally, this is so-called bound notation, business object notation. This is our standard for preparing documents for the lab and for the projects. It's basically just a way to show the relationship between classes, client-supplier inheritance, and that's something we're going to do throughout the course. I'll give you examples later, but I would say the link I provide there, maybe only go there when you need it, just as a reference point, like a dictionary. You don't have to read it through. No, don't do it. Guys, I would suggest, since everything is available online, maybe not take photos. It's kind of distracting to me, if you don't mind. Okay? Yeah. If you miss anything, that's okay. If you miss anything, I'll just send it to you, all right? Okay, let's continue. Okay, and then that's about the reference books. And remember in Lab 0, there's also a link to a wiki site for getting started with iPhone. That's also a site you want to spend some time exploring with. Any source code we posted there, you can reuse it for your lab or projects. So you'll find many things that are useful. Okay? So what's the best way to learn a new language? You don't simply just go to the formal syntax documents like a context-free grammar, like what you learned in 2001. You don't read the context-free grammar to learn a new language. How do you learn it? Examples. Learn from examples and do labs, do projects. That's the best way to learn. Okay? That's why we actually got a wiki site for you. So just do explore that. It's open source for you. Okay, lectures and labs. And do go to every lab, and because I will be there, Tia will be there to answer your questions. And also lab tests and midterm will also take place there. I'll talk about them in just a moment. Okay, for attendance, again, I don't check attendance. That will be wasting your time, but I do encourage you to come. Lab test, I'll give you preparation guide about the lab test. But basically, there will be like a computer test, and that would be testing your ability to write IFO code. I shouldn't say IFO code, to write design that can be implemented and also can be testable. Okay, I'll mention more details about it. Okay. But 1 week before the lab test, 1 or 2 weeks before the lab test, I'll give you a study guide to tell you exactly how you should prepare. Okay, grading scheme. There will be 5 lab submissions, 4% each. And each lab will be some components for software. You got to write in IFO. And there'll be 2% you have to prepare some simple documents. Most likely maybe documenting some important design decisions or to prepare some bond diagram. Okay, examples. And then we got a big project. Project will be released roughly after the midterm. So we're talking about maybe the last month of the course you will be doing the projects. And again, 2 parts for the project, software and documentation. And we got 1 midterm. The midterm test is not computer test, just written test. But it will take place in the lab as well. Maybe some multiple choice, some design questions there where you have to judge your answer by writing. Okay. And lab test, which is purely computer test. And since you guys are in the 3rd year, the lab test over here, we require that whatever you submit should be runnable by the computer. So that should be reasonable to expect, right? Which means if you give me something that does not compile, 0. Okay? Let me terrify you just at the first class so you can get prepared for that. Okay? However, on the other hand, the lab test only occurred in the last week of the course. It's not occurring next week, so don't worry. As long as you did your labs, you did your projects, you did everything you're supposed to do, I don't think that will be hard. Okay? Final exam would be, just standard final exam. The exam will be common to both sections. Okay, I'll talk more about the exam later. Okay. Also for the midterm test, I'll give you some study tips when it comes closer. Okay, let me just go to, okay, that's a grading, any question about the grading scheme? Yes.
So only the final exams common to both sections, or everything else?
The question was only exam was common to both sections. The lab test is also common to both sections. However, to ensure fairness, we also got different versions. I wouldn't tell you how many versions we have. We have different versions, but there will be, what we can ensure is they will be at the same level of difficulty. Okay, sounds fair? Okay. Or should we give CS session a difficult one?
Yes.
No? Okay. So you guys are CS session, right? The other one is engineering, yes.
So Professor, I have a question when it comes to the for the labs. Are they going to be marked by the TA directly like in front of you, or do you submit it via web submit?
Yeah, good question. The question about how do you submit the labs. So all the lab submissions are going to be done by just submit command, like what you did in 2030. No web submit, okay? How do we evaluate them? I can tell you that basically two parts. For the software part, we're going to run some automated unit testing on your code. If your code doesn't compile, 0. If you pass all the tests, you got 4 marks, okay? It's that easy. And for the documentation part, the TA will grade your report and maybe give you some feedback, like how you can improve. Yes?
For the labs, are we working with partners?
For labs, it will be individual work. Okay. However, for project, we do allow, I will tell you the exact number, but maybe possibly up to 2 or 3 members. Yeah. Okay. Questions? Yeah. Does each lab require documentation? I would say in principle, yes. But when you see the lab instruction, you will see exactly what you should do. So don't worry now. Okay, any questions? Are we okay? Okay, guys, if you anything not clear, you should ask today. Yes?
So do we have to submit the labs viewing the lab?
No. The question was, do you have to submit the labs during the lab session? No. Usually let me show you one timetable to give you an example. The next page on the syllabus over here is like a schedule over here. For example, you can see week 1, which just passed, September 5th, where you came to the lab and do lab number 0, right? Now, by the way, there's no submission required for lab number 0. But let me emphasize this. For week 1, it's a golden opportunity for you to get prepared. So what is what I recommend you do, strongly recommend you do. First, finish lab 0. Second, install iFlow Studio. And third, finish that tutorial series. I know it is long, but finish that, okay? All right, and then let's say, for example, here, lab 1, you can see you're supposed to come to the labs and do lab number 1 for the lab session, for the 2 lab session on the 12th and 19th of September. And you can assume usually the lab will be due maybe 1 or 2 days after the last lab session assigned to the lab. For example, you can say, maybe, I'll just say for example, not necessarily true. For example, you can see the last lab session for you to do lab 1 would be September 19th, Wednesday. The due date can be 21st, Friday, midnight, for example. Okay? Yes? Yes, if you can complete the lab during the lab session, which I think you should be able to, that'll be great. But maybe your colleagues, maybe they require more time to think through the issues. They want to talk to me, talk to the TA. We do give them some flexibility there to say, come to the lab session, ask questions, and go back home and do more work and come back again, right? So it's completely flexible.
And you said that you'd be posting the labs themselves like the day before?
I tell you what, the release date, I don't want to commit right now, but I would say definitely when you come to the lab session, you will have the lab instructions. That's what I can guarantee. I mean, sometimes, well, I hope not. Sometimes it can be just 1 hour before the lab session because I'm creating fresh labs this semester, right? Which is good for you guys, right? You don't want to really get any unfairness because your colleagues can actually get maybe a solution from GitHub from the previous semester, right? So you got fresh labs this semester and fresh project. Okay. All right, and you may want to copy down this date. October 24th in your lab session is the midterm test. It's after reading week. I cannot guarantee now, but what I will try to do for your benefit, maybe during the reading week, I'll try to see if I can reserve the lecture hall so we can hold some review session. Come here and ask questions to help you. But I will give you more details later. But October 24th, midterm test. I believe after we grade the midterm, and then you still have a few days to decide if you want to drop the course or not. Okay? We chose the day kind of with that intention. And your only lab test is in the very last lab session, which is November 28th. Okay? So these are the 2 most important dates. They won't change. Okay. Any questions up to now? Good? Okay, let's move on. And this is just a tentative calendar of topics. I will try to follow them more or less, but sometimes I might be a little bit behind. Sometimes I might skip some topics, but don't worry. Whatever I cover, they will be covering the exam. But if there's any extra reading I want you to do, I'll let you know. Okay? Okay, that's about syllabus. Any questions? The question was, that's a very valid and good question. The question was, in 2.5 months, can I actually learn IFO and do well in the lab test? Absolutely, yes. Guys, think in this way. Let's be reasonable. You are supposed to be trained as computer scientists, right? I can guarantee once you graduate from this degree and you go to a new company, you're definitely going to eventually use a language that you never programmed before. Maybe there might be a new language, maybe Java or maybe C#, they will go obsolete at some point. And then you have to learn a new language. How many weeks or how many months do you think your boss will give to you? Maybe just a few weeks, right? I guess, right? Unless it's a very kind boss, right? So I would say, of course, giving you the hard time to learn a new language is not the main intention for this course. Absolutely not. It's just byproducts, okay? It basically, in this course, even though you had to learn a new language, but we do give you time. We give you all the TA support. I try to make myself available as much as possible to you. You can always come talk to me. If you really think this syntax doesn't make sense to you, just talk to me. I can try to help you understand. But you do have 2.5 months to prepare, more than enough. Okay, right? Yes?
I have a question about the book.
Yes.
So how important would you say that is? Like, are you going to be asking random?
Good. Valid question. The question is how important it is to read a textbook. Let me be 100% honest to you. When I was taking this course, 2005 maybe, or 2004, and I also got the same required textbook, I only read it when I need to. I mainly focus on professor's notes. Okay, but if you're in my section, I would say your first priority is make sure you understand everything I say in the class, everything. Slides, illustrations, source code, that will be your first priority to understand. And then if there's any assigned reading, I would say for your benefits of learning, right? You want to really go there and study the book as well. That's for your benefits. And would I put any random questions in the textbook? I wouldn't say random. How about this? If I'm really going to ask a particular section in the book, in the exam, that you may not have studied so far, I'll let you know. How about that? But you don't want to only do this last minute study one day before the exam, right? Right. Okay, questions? That's a very good question. I'm going to answer that for the rest of the lecture. Bear with me. Why do we choose IFO rather than Java? There's a very important reason there, even though you don't agree. You may or may not agree. I gave a guest lecture yesterday for the engineering section. Quite many people talk to me saying, oh yeah, it's a good choice. Yeah, well, you can tell me if you buy my idea, but we'll see. Okay, how about that? Again, this is a university, right? You disagree or agree for a reason. Don't just say you hate IFO. That's emotional. You don't want to be emotional. You want to be rational. You want to be logical. That's really to your best interest. I'll try to be logical there, okay, when I try to justify. Not just because I'm the professor, I want you to learn IFO. It's not that, okay? Any other questions? Yes? Say that again, I don't quite catch your question.
Is it just used right now for teaching, or would you also have...
You mean IFO?
Yeah.
The question was, how is IFO really used in industry? I can tell you that IFO is not as popular as Java or C# in the industry. That's true. But we do know some financial industries or some stock market companies, they do use IFO. But they don't really publicize that too much. Okay, but let's say this. I'm going to justify with reason. If you still got concern, please raise a question or talk to me after class. Okay? Okay, any other questions? Okay, are we okay? Let's go. Let's now see if there's anything else on the syllabus. Okay, you can read through the topics yourself. Okay, course syllabus. Okay, one more thing. For any one of you who needs some accommodation for any personal reason, please get in touch with me by email or just drop by my office hour or talk to me outside after class. Okay, I'll do my best. Okay, any questions before we do some Java?
Yay,
Java. Well, actually, you know what? After you see the example I showed to you, you might be glad we didn't have to do this course in Java. You might be glad. Yes?
Would it be like this? Now I have to
Not necessarily true. I tell you why. We'll see the example. Java, of course, you're very familiar with the syntax. However, the scaffolding you have to build in Java in order to do good design is way too tedious and also error prone, as I will show you, even for simple example. That is why learning a new language, even though syntax is different, but it's not completely far apart from your experience so far. As I said, if I were you, I would just pick it up in 2 weeks by the first 2 labs, okay? Okay, good. Any other questions? Yeah? Okay, let's do it. Okay, let's now go to this lecture here, okay? For the rest of the lecture, I would like to, so here's the roadmap. I want to first talk about why design is important. This course is about software design. It is not about software implementation. I want to justify why design is important. And then I will talk about what design is. I'll talk about what a good design is. And then I'll use that criterion for justifying why Java may not be a very good choice for teaching you design. That's going to be the roadmap. Okay, let's see. First of all, let me show you so this slide here, I'm going to show you some paper if you're interested. This is published by IBM, white paper back in 2008, like 10 years ago, but the idea still applies. Basically, they're trying to say, to minimize development costs for your company, you better minimize software defects. Basically, you don't want to have too many bugs in your software, right? That's how you minimize the cost. But how do we do that? Now, the cost of fixing defects increases exponentially as software progresses through the development cycle. So what's development cycle? Okay, let me just tell you what the development cycle is. Typically, you start with requirements. Requirements, for those of you who are interested, you can take 4312 later, requirements engineering. But requirements usually is simply expressed by the customer using natural language. It can be English, just any language, English, Korean, Chinese, whatever language it is. Okay, requirements. And then you have to somehow elicitate the requirements and turn that into design. Design is not yet implementation. It could be executable, but not yet the final implementation you have to commit to. And then the implementation from the design, and then release. What you have learned so far in 2030, 2011, even 3101, is more about how you can create good implementation, efficient data structure. Okay? But what you really haven't really touched so far is about how to do design. And you might be asking why design is so important. So we're going to show you some statistics. Okay? Basically, we're saying that, okay, let's just get that intuition here before I show you the numbers. We always start with the requirements, and then move on to design, and then move on to implementation, and then we move on to release. Let's say if I find a bug in the design phase, scenario number 1, versus if I find a bug in the release phase, which one will be more costly for me to fix? No wonder release, right? Because if you actually find a bug in the release, you got to trace the bug all the way back to maybe the relevant modules, or you may have, if I had to trace back to requirements or design, it's much more costly. Okay, your intuition is absolutely correct. So can we extrapolate from this? That means if you can get a good design in the first place, it'll be much better to say you got a very crappy design, informal design, but you got very efficient implementation, but maybe somehow it's not so correct. Which one will be more worth doing? You might want to spend more time on the design in the first place. Okay, that's kind of the intuition. But let me show you some numbers to convince you. I didn't make it up. Okay, so that means you want to catch the bugs as early as possible, and then this is the number. Okay, let me try to help you read that. So this means if we say that if you can find a single bug in the design phase, it costs one unit. It doesn't mean $1. Let's say 1 unit. If you find that in the implementation phase, it's 5 times the cost. If you find that in the release phase, it's going to be 30 times the cost. So if you're the manager, you should be wise and make the relevant choice, right? Which part do you want to focus more? Design. And, okay, so far so good? Okay, so that means you want to discover defects, as early as possible. And so that's why the choice of your design language has to be suitable. It's very important, okay? How you do design. Now, so let me just go one step further from there. Do you think, well, I shouldn't say do you think, so should we think that Java is a good design language? So now we have a very clear separation between design and also implementation. I will define what design really means in the next slide. But we want to say choosing a language for implementation is a different concern from choosing a design language. If you want to choose a good implementation language, Java can be a good candidate because Java has many many API libraries, array list, hash table, lots of stuff over there because user community is so big. So it's a good implementation language. On the other hand, can Java be really a good design language? Let's be a little bit open-minded. Let's say, we don't say for sure. Now, let's be open-minded. Don't be so emotionally attached to Java just because it was your first language, right? You don't have to be. You don't have to. We are scientists.
Actually, my first language was Turing,
Turing, okay.
and then Visual Basic.
Anyway, I'm saying your first serious study about computer science was Java, right? Anyway, okay, guys, are we okay so far? Basically, I'm just trying to give you reasoning. First of all, this slide tells you if you can find a bug in the design phase, you should do it. Don't wait until the implementation. But to do the good design, you want to choose an appropriate language. But now, what do I really mean by an appropriate design language? We're going to see that. Okay. Okay. If you're interested in reading the whole paper, I give you a reference here. Okay. Just click on the link, and then you will be able to see the paper. Okay? You can just read through the first page. The figure is exactly there. Okay, what this course is really about. Let me just talk about what this course should be about, and then I'll talk about design, good design, and then do design in Java. That'll be it. So the focus for this course is design, not implementation. So let's make some definition for design. First aspect is about architecture. So we have many interrelated modules. Notice that I'm using the word modules as opposed to classes. Classes are very specific terms for object-oriented language, but you don't necessarily have to always use object-oriented language. You might use C, you might use Python, you might use Haskell, like a functional language. So they might have different notions about modules. It can be just functions, put the different header files, right? So I'm talking about modules. You don't really want to have a Superman module, which does everything. That's definitely bad. You always want to decompose your module into sub-modules according to their individual functionality and let them work together. Another comes a second concern. If you want modules to work together, let's say this. Let's say you implement array list and I want to use it. And you have so many methods or so many functions over there and I want to use them. How do I know which function I should really choose? I should really look at the API, right? I should look at the signature. I should look at the description in English. That's what you did usually in Java, right? However, we'll learn later, if you only specify how individual modules function should work in English, it's not good enough. Because when you talk about complicated functions, using a natural language to specify is simply not sufficient. What's the best language to use? Pseudocode, well, in some ways, pseudocode is still code, right? It's a too low level. Math.
What?
Math. And, well, of course, you got many branches of math, right? The best, I'm talking about 1019. Logic. Okay? That's actually, well, you will be amazed.
What? How?
When you guys learn about 1019, maybe several semesters ago, you wouldn't really see what the use of that is. You will see that in this course. You will learn that, as we'll force you to do, when you want to really specify your individual modules, you have to somehow use executable math. Does it make sense? Executable math, which means you can specify mathematical concepts like what you learned in 1019 in IFO in such a way that you can run unit tests on them and make sure they're correct. That's one advantage for IFO. On the other hand, Java doesn't have that support. Anyway, I'll get to that. Okay, so it might be counterintuitive to you why we can use math. Okay, you'll see later. Let's not talk about math just today. Okay, architecture and specification. So these are the two important aspects. If your choice of language for design cannot really support these two very well, then it may not be a very suitable language. Java can support architecture very well. You can do attributes, you can do inheritance, you can do polymorphism, you can do dynamic binding. Good. IFO can do that too. However, if you talk about specification, that's the part I would like to criticize on Java today, using a simple example to show you. You cannot do that so precisely. You have to do it in a way that's very indirect and tedious and error-prone. Okay, for this course, for this course, the main idea is about design. On the other hand, we want to make sure you can implement your design. So this certain code you have to write. So, however, we only care about the correctness. So you don't have to be so worried about having the most efficient code possible, like back in 3111. You don't have to worry about big O, okay? You don't have to. That's not the focus for this course. So we do have a remark to make just for today. So you can assume that whatever design you have in IFO for this course, you may later on refine that, which is beyond the scope of this course, into certain efficient data structure, right? So for example, you can simply use array to do, for example, you can just use selection sort. But I can imagine that later on you're going to implement that using a binary search tree, balanced binary search tree, right? Things like that. Okay, so now having a suitable language for design matters the most. And now the question is Java also a good design language? As I said, let's be open-minded. Okay, let's try with some small example. And the answer is, let's just understand what a good design is. Okay, before I show you Java code, let's just understand what a good design is. And we don't talk about any language here, just good design in general. Okay, so this will be also some introduction about the terminology you might have heard in the tutorial videos or in Lab 0. Let me clarify the terms over here. Client, supplier, and contracts. I believe you guys heard a little bit or learned a little bit about client and supplier and preconditions in 2030. Okay, let me try to maybe give a little bit more formal definition of what a client is, what a supplier is, what their mutual benefits and obligations are, and what a contract is, and when can you have a contract violation, things like that. Okay, let's try. Okay, a supplier simply provides some service. For the purpose of this slide, let's use a microwave example. Okay, so the supplier in this case is a microwave manufacturer. Okay, and the client in this case will be just the microwave user. You simply use the service. And the client-supplier concept is completely generic, which means, for example, you have been a client and supplier all the time in 2011 or 2030. Can you see how? For example, when you try to use array list in your lab, you are the clients. Array list is the supplier. Okay, and then let's say when you try to do a lab project and get graded, in that case, you are the supplier. And who's the clients? Professor, instructor, because they will use your code and grade it, right? So they're the client to use your code, right? So everybody can be the supplier and clients at the same time, depending on the context. Okay, just some example here. But anyway, let's come back to the microwave example here. Okay, let me just go through the little bit wording here, about read it through to you. So the clients are required to follow certain instructions to obtain the service, which means, let's say for example, for the microwave manufacturer, they assume the user is going to read the manual for the microwave and follow certain instructions, right? For example, before you heat the stuff, turn on the microwave, close the door, and make sure you put in something that's not explosive, for example, right? So these are the 3 instructions, let's say. And the supplier is not going to be responsible for any unsatisfactory service if you don't follow any of the instructions, right? Let's say somehow you didn't turn on your microwave and you complain, it doesn't work, right? It's not right. Okay, that's about the client side. And then for the supplier, if the instructions are followed by the clients, the supplier should really guarantee, should really satisfy whatever that's guaranteed. Should heat the stuff, right, for the microwave. For example, if you put a lunchbox there. Okay, and pretty much like usual, the client only cares about what's really being provided. How the supplier does it is completely hidden from the client, right? So when you use the array list in Java, you don't actually have to care about how each method is actually implemented. Okay. Okay, now let's go a little bit, do a little bit of quiz over here, just test your intuition. So here we talk about client and supplier, and very informally, what's something that the supplier can assume, and what's something that supplier should really guarantee. So now we make it a little bit more formal to make a table to illustrate. So we talk about benefits and obligations. Okay, benefits and obligation here. So let's say we start with the clients. Based on what we said above, what's really the, let's talk about obligation first, that's easier. What's the obligation for clients? Follow the instructions, right? Right? Okay. What about benefits?
When the client doesn't need to know how the microwave is made.
Good. You know, that's good thing. Of course, for me as a client, I only have to know how to use it. Yeah, that's one benefit, but that's not the most important benefits. Yes.
So essentially, you know if it works or not, the why part, not the how part. Like when you use a car, you don't understand the engineering.
Well, true. You know, okay. Let's say I drive. Yeah, if I drive a car, right? What's really the benefits I get? Of course, you know, I don't have to know how to engineer a car. I don't have to. But the main benefit is really I can drive from my home to York, right? I can commute, right? It's more like a purpose. So in this case, the client's benefit really is they can get whatever service they're requesting from the supplier, right? Yep. Of course, the client does not have to care about how the supplier implements that. That's more like a second issue, right? Okay, good. So that's about the first row. So the client obtain a service, and at the same time, they want to make sure they follow the instruction. If they do not follow the instruction, no service can be guaranteed. Okay? Now, let's go to the second row. Now, how do you think we should change for the second row? Would it be identical? Which means the obligation and benefits will be completely identical to the client for the supplier.
The supplier will fix the code.
Supplier will fix the code.
For obligation.
For obligation, well, you're saying that when things don't work, right? Yeah.
Supplier gets to give instructions.
So you give instructions. That's one thing. But what's more important is what if the instruction is actually given and followed? Then is there any other obligation for supplier?
No, that's the benefit. He gets to give instructions.
Oh, he gets a given instruction. Good. Okay. Supplier. Okay. How about put it this way? The supplier does not have to provide a service unconditionally. So for me as a manufacturer, I don't have to worry about if the appliance keep the microwave off power and open the door, put something explosive, I can still heat it. Right? It's not unconditional support. Yeah.
So you only give support, like you only promise that your thing works, given that they actually follow.
Exactly. Exactly.
Otherwise,
So.
it's your fault. If it's not, then it's
Exactly. Okay.
client's
So
fault.
here, this remember, and let me just do a little bit of math over here to be precise. Guys, do you remember what this is? Give me one moment. Remember that? Implication. Okay. Let's do a little bit of math over here to link. Okay, let's talk about this guy here first. P, antecedent, right, logically speaking. Let's say this is, let me just put it a little bit more like a Boolean. Instructions followed. Okay, that's the P. And Q is more like service provided. Okay, let's do a truth table. Okay, this might be the first time you will see this kind of example, I guess. Let's do a truth table. You should know how many rows we should have, right? How many rows? 4. Good, good, good. Not too bad. Not too bad. Let me put it this way. How about this? Let me say, PQ. Okay, this is how I do it. Okay, and then P implies Q. Okay, let me do row by row. Okay, bear with me. So let's say true, 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 false, false, true, false, false, right? Okay. Am I right? Yeah. Okay, good. Okay. I hope I didn't miss anything here. Good. Okay, now, let's talk about the first row. What does the first row mean?
The instructions have been followed correctly and the service has been provided.
Yeah, so now,
Fine, you're happy.
okay, no, who is happy?
Client is happy.
You should say the contract is happy. I like that. That which means the contract is honored. Okay, I'm just using a little bit more formal language. I'll put green here. So now here, this is what I would say. So when you say P and Q is true, is the contract honored? Okay, let's now do the second row. Hopefully get a little bit more intuition. What about the second row? We know logically speaking that should be false, but how do we interpret that? Yeah, exactly. I turn on the microwave, I close the door, I also put in my lunchbox, which is not explosive, but it's not heated. In that means, that means the contract was broken. The contract was violated. Agree? Okay, so that means over here, contract is violated. In this case, who should we decide to blame? Supplier, right? Right? Because supplier to blame. Supplier. Okay, now next one. Next one, how about this? We do this one here first. False, false. This one is interesting. Logically speaking, what should that be? True. What does that mean? How do you interpret that? True. Okay, I don't follow the instruction, and it happens that the microwave doesn't work. So has the contract been violated? No, because as long as the instruction is not satisfied, is not followed, it doesn't matter if the service provider can do it or not. Doesn't matter. Just doesn't matter. Okay, so over here, you can see that over here, it's over here. That's true. And now let's try to see this one over here. What does this one really mean? The third row, false and true. Logically speaking, what is that? Yeah, so that means we got a very magical supplier, right? If you try to interpret the logic here. Okay, so the third row simply means the instruction was not followed, but somehow supplier can still do it. May or may not happen in real life, but that's what it says logically, yeah.
Professor, does that imply that the design is not good?
Good question. So the question was, does that mean something about the design? You can see that over here, P is simply false, which means it's never possible to satisfy the instruction, right? That means your instruction criteria is way too strict. That means no input values can be accepted by your program. And there's an issue there. Okay, I think that'll be enough. We try to keep our discussion in language independent. Okay, that one there, even though it may not happen in real life, but that's what it means logically. Okay, guys, hopefully that can convince you just a tiny bit about how logic can be useful, right? We make things very precise over here. And also, that's how we define if a contract is violated or not. Okay? So the only place where the contract is violated is here. Contract violated. That's the only place. Do think about this implication over here. That's the most important predicate. One of the most important predicates for this course. Okay? Good. Okay, let's go back over here. Oops, not this one. Okay, so for supplier, the benefits would be they can assume they don't have to offer the service unconditionally. The obligation is if the instruction were followed, they got to provide it. Otherwise, contract is violated. Okay, and there might be a contract violation between, so there's always a contract, right? To say between the supplier and the clients. Then when the instruction are not followed, we know that client to be blamed, right? And also if the service is not satisfactory, and that should be the supplier's fault, right? Any questions so far? Okay, good. And you can start thinking about how do we somehow reflect such client-supplier relationship about the expectation from both sides. How can we express such concern in Java? Think about it. From the supplier's point of view, how can I say I can only accept certain inputs? And also from the client's point of view, how can I see from the supplier's API what service would I get after calling the method? Yeah? But you don't have to answer me now. Just keep that thought to your mind. Okay, we're going to see. Yeah, I'm talking about interface. Yeah, just keep your thoughts in your mind. You know what? How about this? Keep your thoughts, and you might just thinking about the same thing as I did in the slides. If it is different, we'll discuss. How about that? Okay. Yes.
Can you go back to your notes for a second?
Of course. Which notes? iPad or slides? iPad.
So here you said the only time the contract violated is the second row.
Mm-hmm.
But in this slide you said if the instructions weren't followed.
Oh, it's different. So here you can see that, okay, it's a very good question. You can see over there, for the row I highlighted as red, it's just logically speaking, that's when the overall contract is violated. However, there's another case over here I want to emphasize here. You can see over here, right? So these are the two cases, even though logically speaking, the contract is not violated. However, you can see in this case, the clients have not fulfilled their obligations, right? So there should be some signal about this at the runtime. Okay? Yeah, I know I'm kind of mixing the logic and runtime together, but try to incorporate these two concepts in your mind. It's quite important, right? We don't want to talk about just pure theories. We do want you to apply this to your code and also to your design. Okay? Let me just make a note over here. So here, even though it is true logically, some kind of, I would say, error should be reported about the client's faults. Okay? Yeah. But guys, don't be too worried if you cannot catch the notes. Don't worry. I'm going to make the PDF for you for the iPad notes. Yeah. Okay, good. Let me switch back. Does that answer your questions? Maybe? Yes, I forgot which one. Okay, anyway, yeah. Okay, now, client-supplier contract OOP. Okay, let's do, even though I said I wouldn't do Java just yet, but let's consider a little bit Java. Okay, nothing to criticize about Java. That's the good thing about, that's the part I can show in any OOP, object-oriented programming language. Now, let's put the microwave and microwave user into context. Okay. So now we got microwave, and we got two attributes on and locked, right? And also we have two methods there, can power on and also locked. And also we got a heat method here. So this is the main service we want to provide as a supplier, right? And the heat is going to take some object here over here. And then the supplier kind of assume when you try to hit some object over here, it better be that the current attributes for on should be true. And the lock should be true. And also the object there must be not explosive, right? That kind of implicit assumption. But there's nothing reflected to be checked at runtime over here, just comments. And then microwave user supplier over here. And then we have microwave objects. Questions? Yes?
Where it says assume on and lock, we still have to check that.
Yeah, so that's up to your implementation. Of course, back in 2030, we say you can do exceptions, right? That's exactly what we will do in Java. Yeah, good, yeah. However, think to yourself, how do we express the idea to say, at the end of the method, the lunchbox or whatever object, the stuff there is properly heated? How would you say that? Something like that.
Tests, you can get close to it, but you can never really do it.
Well, exactly, that's a limitation for Java, isn't it? Right? Good. So guys, keep thinking about how you would do such things, especially express the contracts, expectation from the supplier, expectation from the client. How would you express them programmatically in Java? If you can do it, but in a way that's very tedious, very complicated, that means Java may not be a very good language for design. Okay? Microwave, and then object here. The reason I put question mark there simply means, let's say we don't know what the object is. Okay? Now let's consider this method, and then m.power, m.lock, and then m.heat. Okay? Okay, you're so far so good. You have the code. Let me just switch back to iPad. I do want to emphasize one thing, and then I'll have a question for you. The same code over here. So now, I want you to pay attention to this line over here. M.heat objects. Okay. Now, tell me who the client is, who the supplier is. Who's the client? Who's the supplier? Now, how do you know the supplier is a microwave?
We initialize the object there.
And the object's type is microwave. Okay, let me be a little bit more precise about a supplier over here. First of all, you can see that, of course, this applies to any object-oriented programming. So over here, you can see that we are calling this method here, but what's more important is so-called context objects. The context object over here is M, which was declared as microwave, which is over here. That's how you see it's a supplier. On the other hand, how do we see who the client is?
The object that is in use, for example, obj object.
So yeah, so that's how you can see we're making this call in the context of microwave user class. That's a little bit more formal answer. Yeah, want to say something? Okay, good. How do we? Let me just write it down. So over here, let me say this. Over here, call in the context of microwave user. Okay, I'll say MU just for short. Microwave user class. So that means this class is the supplier. Client, sorry. Sometimes I do make mistake. Please feel free to correct me. I do make mistake. Okay, and then microwave, as I said before, that should be the supplier. Okay, client supplier. Just in general, if you see any method call, that's how you decide who the client is, who the supplier is. Okay, let's get it through. Yeah? The square brackets over there simply tells me that I don't know what it is. Something, just something. Okay, now I want to introduce two more terms over here. Okay, the two critical timings you have to pay attention to. Okay, which we'll emphasize more next week. Red will be good. So okay, let me put it this way. Let's say we try to call this method m.heat, and then we pass object as the arguments over here. Okay, now I want you to focus on two timings over here. Immediately before calling this method here, and versus immediately after calling the method. Okay? Now, let's talk about, again, client-supplier obligation benefits over here, right? There is some name for the green arrow over there, the timing. It is so-called the pre-states, which means it is the state of the objects before I call this method here, right? And then also over here is called the post-states. We can say before states, after state is also fine. Okay, pre and post, or before and after. So now let's say in the pre-states over there, what's kind of the condition we have to satisfy in order to make sure the contract is not really violated, or at least there's no side to blame. How about that? Okay, object must not be explosive, and also m.on should be true, m.locked should be true, right? Okay, good. So that means in the pre-state, right before we call the method there, it would be that client's obligation must be true. Must be true. Okay, it's a very critical concept, okay? Symmetrically, let's say in the pre-states, clients do satisfy their obligations, and we go ahead and execute the body of the method, and what should be satisfied in the post-states? It should be heated, or in a more general sense, the obligation of the supplier must be satisfied, right? Okay, let me just put it out. Supplier obligation also must be satisfied, true. Yes?
Every time you initialize an object, are you the client?
Good question. When you say when you say every time you initialize an object, right? That's okay. Let's say this. How about this? Let's say class point tester. Right? That must be a very cliche example, but I'll just use it anyway. So main method over here. Inside the main method, I would say point p is assigned to new point. So I'm trying to initialize an object called p over here. So now we can know that at this point, how can we judge who's the client, who's the supplier?
Well, point tester is initialized
Yeah, but somehow, remember, we are also using a surface here. What kind of surface are we using? We are using the surface from the point constructor to initialize the point objects. So its surface, the surface we got provided was get a new objects. We might do some method call later, but not at this point, right? Good. Okay, so let me just make it clear. It's a very good question, actually. It complements what I just said. So point over here is surface of constructing a new objects. A new objects. And P will be used as the supplier. And in the context of this, we do this, so that will be the clients. Okay? Clear, everybody? Good. Okay, let's go back to where we were over here. Okay, that's about the pre-state and post-states. Okay, any questions so far? Okay. We still got about maybe 15 minutes or so. We may not be able to go over all the Java code, but at least I'll go over a few versions. I'll complete next time. But are we okay so far? It's really important. Okay. So far, nothing about Java, nothing about IFO. Just about how you understand contracts, client, supplier in object-oriented programming, which can be applied to C#, to any other object-oriented language. Okay? Okay, let's go back to the slides and see what's next. Okay, pretty much what I said. Okay, you can just go through them. Okay, I don't need to repeat them. Okay, and then the contracts honor exactly what you guys said. You can say before the method call, what should be satisfied, and also after the method call, what should be satisfied. And there might be some violation, which means there should be one side to be blamed. Oh, let me mention one more thing. When I say over here, talk about the pre-states over here, right? When I say the client's obligation is true, thinking this way, also that means the supplier's benefits are also true, right? Remember, they're the same, okay? Symmetrically, over here, when I say the supplier's obligation is true, that means the client's benefits are also true, right? These are the two equivalent things. That means the client's benefits are also true. If you cannot really read my writing when you see the PDF, maybe you just go back to recording and listen to what I say, and then you can figure out exactly what I'm writing, okay? I try to practice, but that's the best I could do. Okay. Any questions? Okay, you can always bring the PDF to me, and then hopefully I can recognize my writing. Hopefully. Yes, go ahead. Is this similar to precondition, postcondition, class invariant? Absolutely. So here, you can see here we talk about just a very general concept, more like a business, right? We talk about contract, supplier, clients. We'll move on to something that you can program. That's fine. That's fine. Don't worry about it. Yes, questions?
On the micro class needs a constructor to actually, create object user class.
Guys, could you please calm down? It's fine. Yeah. Yes.
The microwave user class, the microwave class needs
Yes.
to have a constructor to be able to.
Oh, yeah. Here I'm just showing you the idea, right? You can feel free to make it more complete. I'm just trying to show you. So here, the main surface we are requesting is the heat method. But I just didn't put any implementation there. But, you wouldn't add any value to illustration, right? Okay. All right. Okay, and then, exactly what I just illustrated, so I can just let you read it, okay? Okay, so now what is a good design? Okay, now we reached this, we just talked about what design is and the architecture specification. We haven't got that yet, but now let's talk about what a good design is. And we use this criterion to judge how well Java can do. Okay, that's kind of the roadmap. We may not be able to have the complete discussion, but we'll try to at least have the critical part of it. A good design should explicitly and unambiguously. Explicitly means you should be able to check obligations and benefits at the runtime using some tests as far as the course is concerned. Unambiguously means you have to express something where you will leave no missing cases. Okay, I'll show you what missing cases might mean later. Okay. Let me put a little bit logical sense, logical turn over here. I wouldn't write it, I'll just mention that. So you actually learn in 1019. So when you say a predicate is too weak, that means the predicate can have too many satisfying values. When you say a predicate is too strong, that means it has too few satisfying values. That's kind of the concern you want to have when you design your precondition or postcondition. I'll emphasize more when we get to the main part of the course, but I'm just mentioning that verbally. Okay, so such contractual relation between client and supplier, specification. And when you want to do software design, you better be guided by the contractual relation between the client and supplier, not by hash table, not by how you implement the balanced binary search tree or how you do the rotation for your AVL tree, right? It's not kind of the level of abstraction you want to maintain. You want to be guided by, overall, what should be the contract between the client and the supplier. You want to make sure it documents the contract in a way that can be checked at the runtime. And your contracts, logically speaking, cannot be too weak or too strong. Okay. Okay, now, instruction for a client should not be unreasonable. Of course, you should not tell the client to, well, just some example, you should not tell them to assemble internal parts of the wire microwave. And also, the benefits for the supplier cannot be unconditional, which means you cannot simply say the supplier will simply, I'll just do any microwave surface for you, even though it's an explosive, right? That's kind of the example I just mentioned. Okay, now let's do a little bit of exercise here. Let's consider something you're very familiar with. Let's say you are the binary search user. Let's say we are trying to call the binary search method on an array. What's your obligation as a caller? Clients. Sorry, yes, exactly, sorry. Let me say it again. You're the user of calling a binary search method. And the binary search method takes as part of the input an array. You want to do a binary search on an array. What's your obligation? Object should not be null, I agree, okay. But something even more. You should provide an array. Yeah, which means array is not null. More. Array is sorted. Exactly. That's a precondition for binary search, right? You want to make sure before you can call the binary search routine, you better pass something that's sorted. Otherwise, it will give you the wrong result. Huh? Oh, yeah, that's more like an implementation issue, right, for comparator, right? Let's not worry about that. I'm more talking about what should be the condition for the input. Okay, the array is sorted, and then, okay, so now, when contract is violated, the worst case you want to have is when both sides are wrong, which means client is wrong and supplier is wrong. You don't want to have that kind of case, right? Basically, it's more useful to say when any kind of error occur at the runtime, one side is to be blamed. Either client to be blamed or supplier to be blamed, okay? Okay, the whole process is called design by contracts. And now, this is our main criterion of judging if a language we choose is a good language for teaching you design, or for you to constructing design. Now, since we are so familiar with since we're so familiar with Java, I'm familiar with IFO, but since we are so familiar with Java for you guys, why don't we do it in Java? Just for one simple example. Okay. We got about 7 minutes. I will see what I can do. At least we do one version. Okay, now let's have a look at this particular problem over here. So we have a bank accounts. So we got several requirements, informal requirements. Requirements number 1, each account has associated name and also balance. And that is always positive. Okay? Requirement number 2, we may withdraw an integer account from an account. We may withdraw an integer amount from an account. Requirements 2 seems to be a little bit vague, but that's intentional. That's also normal for requirements. Okay, that's okay. Okay, we also got requirement number 3, 4, 5, 6. You can feel free to read it, but for the illustration purpose, I will only do requirements 1 and 2. Okay, so let's focus on 1 and 2. I will go back to iPad whenever we need to refer to them. Okay, if you can just take 5 seconds to memorize them very quickly, at least know what 1 is, what 2 is. 1 is about balance being positive, and number 2 is withdrawal. We got to provide some surface for withdrawal. That's it, 1 and 2. So now, how would you do a good design in Java? How would you do it?
Class invariants.
Well, of course you can have class invariant, but there's no keyword called class invariance in Java, right? You somehow have to build some scaffolding to check it, somehow, using assertion, for example. But we'll see that. Okay, class invariant, I like that. Yes?
You have to make some sort of method that you call upon that checks.
That check. Well, somehow you want to perform some checks. I agree. Yeah. How you actually do the checks is kind of more like an implementation specific issue. That's okay. Good answer. You got to check it. Okay, guys, let's do 1 version at least today, and then let's at least get an intuition at which direction I'm heading to. Okay. Okay. Now what we'll do is, okay. Now this may not be as easy as you might think. I got 5 versions for you to criticize upon. We just do version 1. Let's criticize very carefully on version 1, and then on Tuesday, I'm going to talk about the other 4 versions quickly, and then we'll move on to, hopefully, the better design language, iPhone. Okay, let's just go for the first version. Okay, and the source code for Java is completely available to you. Download it and play with it before you come to Tuesday's lecture. And then to do the assertion for class invariance in Java, you need to do certain configuration change in your Eclipse, but you can just go to the tutorial video. I show you how you can do it. Okay, just go there and do it. Okay, version 1, let me show you the code. Let's read the code together. Account V1, version 1. We got owner, we got balance. So that was satisfying requirements 1, right? We got owner, we got balance. And we have accessor method, get owner, get balance. And we got account number 1 constructor here, which takes an owner, takes a balance. And then withdraw, which will simply subtract the amount from the balance. And toString method. Criticism. Balance can be negative in, yes. As you can see in line number 6, the balance can be negative. So that will violate which requirements? Requirements number 1, because remember, for requirements number 1 over here, it's about the balance should be always positive, right? Okay, another one, yes. Yes, for example, if I got $100, I might want to withdraw 150. It shouldn't be allowed, should it? Shouldn't be, okay? And let somebody else to try. Huh? Owner can be null. Okay, sure, I like that. Even though it's not included in my example. Yes. Yes. Yes, that's good concern, even though I didn't put it in my code, but I like that, yes. Yes, yeah, go ahead.
Oh, the amount withdrawn has to be positive.
Yes. Should withdraw minus $1 million be allowed? You'll be great, right? But it shouldn't be. If you know such a bank, let me know. Okay, that's kind of about the criticism. Let me recap. Line number 6, balance might be negative. Line number 9, amount might be negative, or even though it's positive, it might be too big. Okay? And one more issue over here. Remember we said something like the balance should always be positive according to requirements. What does that mean? That means for every instance you can instantiate from the account number 1 class, the balance should always be positive. It's more like a global constraint. Whenever you talk about something global as a property, it's something called invariance. For Java, there's no such a place for you to put a global invariance. Okay? Guys, can I just have 3 more minutes? How about that? Okay.
So,
Questions? Yes, go ahead.
for the balance, should you add an if condition?
Oh, yeah, that's more about the version 2 I'm going to do. Yes. Okay, guys, how about this? This is my plan. Just give me 3 minutes. What I will do is, why don't we do version 2 coding right away? I'll show you version 2, which is a slight improvement to version 1. Let's criticize quickly, and then we are done. Okay? Deal? Okay, version 1, you can just read through the slides, self-contained. Okay? So now let's go to, so that means we're going to do some precondition over there. Okay, I can review the precondition on Tuesday, but let's go to version 2 directly. Let's have some improvement. Now, version 2, so now you can see we do have an if statements over here to say if the balance you're trying to initialize is negative, throw an exception. Okay? And for withdrawal, we got two possible sources of error. If amount is negative, or if the balance is somehow smaller than amount. Okay? Now, criticism, before I tell you something you may not have thought about. Yes, please. Which one?
Like the if statement, you said always.
Well, okay, which line?
5.
Line number 5. If 5, why? If the balance, okay, if the balance is 0, positive, oh, that's true, right? So let's talk about this case over here. So let's think about this. Let's run it through. Let's imagine we had a Java executor, right, at runtime. So now let's say if balance is actually 0, which should be illegal, right? Now 0 less than 0 would be false, which means we would not trigger an exception, but we should. So somehow we say that number 5 is way too strong. We want to make it a little bit weaker. We want to include more cases over here, right? Since you mentioned this, what about line number 11? Oh, sorry, line number 13. Is there any problem there? Yeah, there's a missing case there, right? Let's say if amount is exactly equal to the balance. In that case, balance less than balance will be false. That means you will not trigger an exception, which you should.
Make balance 0, and you can't have balance be 0. It has to be positive.
You have to be positive. Yeah, exactly. Yeah. Okay, guys, so far so good. And now, let me just give you one more criticism. How about that? That's the main criticism today. It's really the highlight of today. Given that we got, okay, line number 6, that's the first kind of exception. Line number 12, that's the second kind of exception. Line number 14, that's number 14 is another kind of exception. Now, imagine that if you want to use the constructor and the withdraw method, what do you have to do? If you want to call these methods, you want to do try and catch, right? How complicated would it be? You're going to say try, and then catch, catch, catch. What if you got 10 preconditions in each method? Catch many times. Okay, that'll be it. Okay, let me just say what you should do over the weekend. Please follow through the tutorial video. You kind of get an idea. I'll finish the example, and we'll go to iPhone on Tuesday.